In this video, we're going to use our X and Z carriages as an assembly just to demonstrate some assembly features. So the first thing I'm going to do is I'm going to start a new assembly. I'll click on the New button. And this is the basic splash screen. And we can choose an assembly from here. Just so you know, if you ever click the Advanced, now you can get to specific templates. So you can have all kinds of different templates. For instance, these ones are all 4mm parts. And here, these ones are set up for whatever it was my initial settings show, which in my case is inches. I'm going to click OK. I happen to know that my components are going to be in millimeters, so I do want to change the coordinate system. But before we do that, what it's asking me to do to begin the assembly is to choose a file. You can see that I've already started. This is I'm in the X carriage components. It's already looking here for different things. I'm going to cancel out of this because I want to do this myself in just a minute. So I'll cancel out of the begin the assembly. I'm going to change the units here to millimeters. Now that I have the units changed for millimeters, let's go ahead and insert a component. It brings me back up to the same thing. The first thing I'm going to insert is something that you should have drawn by yourself. Mine is going to be the imported file, but your assignment was to actually measure and draw the Z carriage. So I'll click Open. It's going to open this as a SolidWorks part. And if you notice, when I drag it around, it'll let me free place it anywhere in the assembly. I want to be careful not to do that. What I want to do is click the check mark. When I click the check mark, you notice it snapped back to the center. And the reason this mattered is now the front plane of my part matches the front plane of the assembly. The right plane of my part matches the right plane of the assembly, and that was the top plane, and the right plane also, the right plane and the right plane match. So what this does, if you click the check mark, it allows the origin of the part you're placing to line up with the origin of the assembly. I think it's good practice to always do that for the first part that you put in. When I'm deciding what part I should first put in the assembly, I want the thing that is most stationary or most normal. So now that I have that part put in, notice it also came in as a fixed component. It doesn't move in space. That's good for your first component. After that, we want everything to be related to the first component. So we're ready to insert something else now. I'm going to use the lead screw nut. We'll bring that next, so I'll click OK. I can drag it and drop it anywhere. This will be fine. And now that it's here, it's going to go in this pocket. So what I'll do is I'll click this outside surface. Holding down Control, I'll click the inside edge here, and I want those two to be collinear. That looks good, and it went the correct direction. If it didn't, there was another. I could make it flip around. And one of the other times I insert in, I'll show you how to flip that around. Now, if you notice, what I did not do is go into the make command. The make command is convenient, so if we open up the make command, we can do things like choosing. If I choose the inside cylinder of that hole and the inside cylinder of this hole here, I can let the two of those be concentric. I'll click the concentric button and click OK, and that will complete the mate. That will finish everything out. And now if you notice here, oops, the lead screw nut is almost all the way locked down. Let's see why it's moving. I'll rotate around a little bit. Remember, that's the middle mouse button. Okay, the lead screw cannot rotate it, or the lead screw nut cannot rotate anymore, and it's stuck inside the correct hole, but it's not fixed at that inside edge. In order to make it fixed, again, instead of going into the make command, I like to use the pop-ups. So I'll click this surface, and I want this surface, and I'm going to hold down Control, this surface, these two surfaces. When I let go of Control, a menu pops up with the basic mates here right in front of me. The one I wanted was coincident. If I don't move my mouse, I have the option to flip the mate. In this case, I don't want to flip the mate, but if it ever moves backwards to what you expected, you can click the flip mate alignment and it'll fix it. Okay, this is now fully constrained. I know it's fully constrained, number one, because if I try to grab it and move it, it doesn't move. And also because over here in the design tree, we can see that lead screw nut does not have a minus sign next to it. That means in the assembly mode that it's fully fixed. Now that we have that component in, the other thing I want to put in here are lead screw nuts. I'm going to show you two different ones. I'm including two of them in your packet. One of them is one that I downloaded from SolidWorks. It's right here. It's called the linear and rotary ball bearing. This looks almost like the one that you actually have. Oops, I just clicked to open the part, not to insert it. But I'll show it to you here. You can see it actually has the ball bearings inside of it. This has a lot of detail. If your computer is really capable, then it would be fine for you to use this. But this has a lot of features and is more complicated than is necessary. So to keep you from having stability issues, I'm not going to use that one. I'm actually going to use the other one. So I clicked Insert Part. And now there's one called Linear Bearing. When I open the linear bearing, it comes in and it's just a rough representation. Notice it does not have the cylinder, the ball bearings inside of it. We want two of these, so I'm going to grab hold of that one. I'll hit Control. Let's see. In the design tree, I'll click linear bearing, Control C. Now click somewhere on the screen and Control V, and it places another one. So now I have two in the assembly. I want to do the same thing I did before. I want to insert these in, but I'll do them slightly differently. This time I'll take this surface here, control this surface. When I let go, I have the option to let it be coincident. That's the wrong way, so I'll flip the mate orientation. That's the correct way, so that's good. Now the next thing I want to do is I want to do a concentric mate, but this time I want to lock the rotation. And what that means is that this would no longer be able to revolve in the hole. This one I didn't lock the rotation because I wanted to use the bolt holes to finish locking the rotation. But this one there's not going to be bolt holes. So I'll click this outside cylinder, this inside cylinder, let go of control, concentric, and now I need to hold my mouse here. I'm going to click the lock rotation button. And if you notice now the linear bearing does not have a minus sign. The linear bearing down below still does because it's not fully constrained. We'll repeat for this process. So click here, control, click here, coincident. It went the wrong way, so flip the orientation. Clicked anywhere to deselect everything. Outside surface, control, inside surface. When I take my finger off control, I can choose concentric and I'll choose fixed rotation. So now this is fully constrained. So I'm going to call this, I need to name this assembly. This is all I need to do for this subassembly. This is my Z carriage assembly. So I'll click Save. And I'm in the X carriage components. We'll call this Z carriage assembly. One other thing we can do here just to make things that look nice. Right now, this has been what I would call a bottom-up design in that I brought in one component, then I brought in another, and each of these components are independent from one another. In that regard, if there's ever anything that I want to edit, so for instance, I want to change the color of this Z carriage. If I right-click on the Z carriage, I have two options. I can open the part, or I can edit the part within the assembly. I would recommend, unless you really know what you're doing, to go ahead and open the part independently. It opens up, it's entirely just the part now. Notice yours should have all the features that you needed to create your part. Mine only has a step file because I imported this. So I'm going to go to Appearances. I've already selected some things, so before I started it looked like this. You had just appearances. I'm going to choose the color appearance. I'll choose a plastic appearance. Actually, before I choose this appearance, let me actually change the material. So I'll deselect everything. We'll take a look at the material right here. If I right-click on the material, we can scroll down here and see some common ones. There's ABS. I think that's what I'm going to use. I'll call it ABS. I know it's actually PLA, but if I go into the Edit Materials and look under the plastics, we'll see that actually PLA is not something that's mentioned here at all. So I don't know how precise it is, but I think we'll call it ABS, and we'll click Apply. Okay, if you notice the color changed just a little bit, the reason it did is there is a color that's associated with ABS. It's not the color I want it to be black. So I'll click Appearances, Again, I've already gone into color or plastic, and now I want it to be a low gloss. And now I'll do a dark gray, and if I pull it to anywhere, any surface, it'll ask me, do I want just the surface or that particular feature? For me, it's the insert whole body. The entire single body, if there were multiple bodies, you would have a difference between this one or the entire part. I'll do it on the part level. So we'll click here, and now that black has been applied to this. I'm going to click Save, so Control S to save it. I'll exit just this one part, which brings me back into the assembly, and you can see that the appearance was conserved, so now the appearance is black here in the assembly. All right, this assembly is finished. I'm going to click Save. And I'm just going to minimize it because we're going to come back to it in just a minute. The next assembly that we want to create is the X carriage. So I'll click, see, I'm still in this component right now. So let me maximize it back. Here we are in the assembly. I want to go to New. And again, if you're in the novice version, you're just going to click Assembly. OK. And now, if you have any files open, they'll show up here already in the Begin Assemblies. I don't have the one I want here, so I'll click Browse. And actually, what I want to insert is the X carriage, but I just remembered I've not yet created the X carriage here, so it's not, I don't see it here. So let me cancel. We'll exit out of this Begin Assembly dialog and minimize it for a minute. I'll click Open, and while I'm here in the Open, if you notice, the X carriage is a .step file. This is the same, I've done this for you, that you're going to import an actual a step file. You click Open, and what it has to do is SOLIDWORKS has to interpret the step file as a SOLIDWORKS file. So it asks, do I want to run the diagnosis? That's typically a good idea, so I'll click Yes. It said there were no problems, so do you want to finish the import? So I'll click OK. And now it comes in as a single solid body. At this point, I want to save. Notice the file name is now xcarriage.sldprt. So click Save. And it asks, is that really what I want to call it? It is, so I'll click Save again. And we'll do the same thing for the material. Notice ABS is here, so I can choose that. And that made it clear. The PC ABS is a clear. That's okay, we'll just choose the color here, low gloss gray. I'll drag it to a surface and choose for the whole body, and now I have a black X carriage. I'm going to click Save, and I'm going to leave it open again, so I'll minimize. And now if you notice, I've got several things down here at the bottom. Here is the assembly that I just started that was unfinished. So I'll click Open, Insert Component. Now the X carriage is what I want to insert, and again I'll click the check mark so the origins line up. And let's take a look at this and make sure we understand what it is we're looking at. It's probably easy to see that we're going to need to put another nut here, and we're going to need to put our linear bearings here in those 4 locations. We also are going to need to put a stepper motor, and that looks like that's going to go here. The stepper motor will stick up, and that will let some other components go. So there's a bearing that's going to go in this area down here in the bottom. So really, it doesn't matter a whole lot what order I do things in, as long as I can be consistent. Since I've already done it once today, let me go ahead and add that nut again. So I'll do Insert Components, Browse. It was the lead screw nut I'm bringing in. I'll click Open, and we'll drop that there. And I'll do it in a little bit different order this time. I'm going to take that surface, control that surface, let them be coincident with each other. Okay. Now I can grab this surface, control inside surface. I'm going to let them be concentric, but this time I'm not going to use the lock rotation. We'll zoom in here. I want that cylinder and this cylinder to also be concentric, and that will lock the rotation. The lead screw nut now does not have a minus sign, so it's fully placed. The next one I want to show you is it's a different way of inserting components. We'll click Insert Component and then Browse, and now we're going to use the linear bearing right here. I'll click Open. But instead of just immediately dropping it, what I'm going to do is click the pin to keep visible. By doing that, I can now place 1, 2, 3, 4 in one motion, put them all in at the same time. So we'll click OK. And now I just need to go through and do each of these. So surface, surface, coincident, switch, surface, control, surface, concentric, lock rotation, and repeat. 1, I took care of those two. Now I'll rotate around so I can see what's going on here at the back side. Notice I was careful not to get the lines. I don't want edges, I want surfaces. Sometimes I will forget to do something. So for instance, let me do it incorrectly this time. Let's say I click the surface here, Control, click the surface here, and I'll click coincident, but then I'm not going to switch it this time. So I'll just click somewhere. I forgot to switch that. So you notice it's mated, but it's in the wrong position. If I drag it and move it, it's still staying in the same plane. But it's the wrong way. I want to flip that mate. What I need to do is first I'll find which one is moving. So this is the component that's moving. Over here we can see it. So I'll expand over here and we can look in its mates and we can look at this coincident mate right here, and I want to edit that mate. We'll go into the edit menu. What I wanted to do was to make it flip the other way. So if you look at the mate alignment here, this is what I currently have where the faces are opposing each other. I want the faces to be the same, so we can go ahead and click it there. So that took care of that. We now have it fixed. The same will also be true for locking the rotation. If I click this surface, Control, click this surface, and I'm going to forget to do, oops, actually let me hit escape. So I wanted to get out of the mate command completely. So I'll click this surface and concentric. And remember this, if I forget to do that lock, all I need to do is go find that concentric mate. So I already have it pulled up. There's the linear bearing expanded, and you can see the mate where they're coincidence, and then underneath it you can see the mate where they're concentric. Notice this does not have a solid filled in inside. That means we did not lock rotation. If I right click on concentric 7 here, the first option here is lock rotation. The symbol changes to where it's bubbled in and the minus sign goes away and it's now fully constrained. So we've got those 4 linear bearings put in, and we also have the lead screw nut placed in there. So that looks good. The next thing let's tackle is the stepper motor. So I've already saved the stepper motor for you as a SolidWorks part. So let me save. This is probably a good spot to save, and we'll call this X Carriage assembly. We are going to insert components, browse. Let's find our stepper motor. There it is. By the way, all of these that have numbers in front of them were downloaded directly from McMaster-Carr. It's a really good source for getting good CAD files for things that you would purchase. I didn't have to buy the motor from McMaster-Carr in order to get their part to dimension. Okay, this looks very similar to what we've done before. We'll take this surface here, control this surface. We'll let the two of those be coincident with one another. And then we'll let this inside cylinder here be concentric with this. I'm hitting control, this inside circle. Oops. Okay. Now this time what I want to do, let me make sure nothing is selected. If I drag the stepper motor, we can drag it all the way around. The way we want it is for the wires to be in the back. So what I'll do is I'll take this surface, and I'm hitting control, and this surface, and this time we'll use the parallel mate to make them line up. That fully mates it. Now, although the stepper motor is actually an assembly, and you can see little bolt pieces, screws, and things like that, SolidWorks views it as a single part because that's how it came in. The single stepper motor is a single part. So there's not assembly components to it, which means that this motor shaft is not capable of spinning. The next thing I want to do is to put the coupler on the shaft, but we're going to need to leave a degree of freedom so that the coupler can still rotate about the shaft. So I'm going to go to Insert Components, Browse. This one right here is not, you can't fully see it, so we'll drag it out so you can. And this is flexible coupling, flexible shaft coupling, SolidWorks part. So we'll open it. This one's made out of aluminum, so it's already modeled as an aluminum component. I'll drop it in here in space. You can see that the diameters are different on the two edges. That's because one of them is for the shaft and the other one is for the lead screw that we'll put in just a minute. Let's go ahead and get this one assembled where we want. I think what I want to do is I want to assume that we're going to put the lead screw, this entire component here will fit, that narrower section will fit on the shaft. So what I can do is I can take that face right there and let that one, I'm holding control now, be coincident with this face here. So we'll let those be coincident. That's the wrong way, so we'll flip it. That's the right way. Now we can take this inside cylinder and this cylinder face here and let them be concentric. And now I'm not going to choose to let it be locking the rotation because I actually want this shaft to be able to rotate. So if you look at it now, if we grab hold of it, we can move it around. That's what we want, 1 degree of freedom. Okay, good. That finishes that, putting that component in for now. We will eventually get to where we are controlling that motion, but for now we'll let it move. Let's go ahead and insert another component. This time I'll get the lead screw. We've got the lead screw nut, so now I need the lead screw. It's a T8 by 2 lead screw, 75 millimeters long. So I'll click Open. This brings in that threaded rod. And I want to do something kind of similar. I'm going to rotate around here. And yeah, the easiest thing to do is to rotate till you get to a place where you can see what you're trying to get to. This is the end of the set of the stepper motor. So I'll click that surface right there. Make sure that is the surface I wanted. It is. And I'll click the end here. I'm holding down Control. I'm going to click the surface. Now instead of the coincident, I'm going to choose the distance. So we'll choose a distance mate, and it assumes the current distance is what we want. That's in inches. Let's change this to 2 millimeters. As I do this, I realize that this particular assembly I never switched over to being in millimeters, so I do want to fix that. The standoff distance is at 2 millimeters, so we'll click OK. And now we're going to click, let's save it, change the units to millimeter gram second. I'm going to choose this cylindrical portion that's on the outside. Rotating around, I'll choose the cylindrical face here, and I had Control selected for that. We'll do concentric, and now I actually do want to lock rotation. So what I'm going to do now is, what that means is, if you notice there's a minus sign next to the T8 and to the lead screw and to the coupling. If I grab the coupling and rotate it, the lead screw rotates with it. So this is simulating what it'll be like to tighten these set screws down onto the lead screw and for the motor to be spinning it. Now the motor won't ever actually really be able to spin because that shaft is not a separate component from the rest of the body of the motor. So we really are simulating what it would look like. Okay, the lead screw comes down here into a bearing housing. Let's go ahead and put in the bearing. So we're going to insert components. Browse. This bearing, there's a ball bearing. It came from McMaster car. And again, this comes in very nicely. It's been set to steel after it was saved as a SOLIDWORKS part. And you can actually see the race in there. This doesn't look exactly like the bearing that we have, but dimensionally it will work. So we'll choose this inside surface, control that surface, coincident. That is the way I wanted it, so that's great. This surface, control this surface, concentric, and lock rotation. Looks good. Okay, there's a Z ring container. I've already converted this one to a SOLIDWORKS part for you. This one is called Z bearing retainer. Open. Oops, I opened the part instead of inserting it in the assembly. So let's try again. Insert component, browse, Z bearing retainer, click open. Here, okay, rotate around so I can see its orientation. There we go. Okay, that surface right here, that surface needs to be coincident with that surface. Okay. This cylindrical face should be concentric with this cylindrical face. And this hole and this hole should be concentric. There we go. Got it rotated around. Notice the Z-bearing retainer doesn't have a minus sign. It really is good practice. This is still a bottom-up assembly design because we're bringing in pieces one at a time and that were created independently. But at this location, at this point, it's handy to notice that the only motion that we're going to allow is this screw right here that can rotate around. So we'll go ahead and insert this one. We're going to mate. I'll choose that surface and this surface, and we want them to be coincident and the way that they're currently located, so click OK. So I did actually use the mate command this time. Since I'm in the mate command, we can click this surface and this surface. And here's the lock rotation if you're using the mate command instead of shift selecting surfaces. So we'll click OK. That's finished. That finished the linear rod. Let's put in another linear rod. So insert, browse, another 100 millimeter linear rod. Drop it in. This surface and this surface needs to be coincident. Good. This surface and this surface needs to be concentric lock rotation. So that fixed that one now. It's fully locked. And the only other component that we have left is a subassembly. So we will go ahead and drop that in. So we'll save, then insert components. And now finally I'll use one that I already had, the Z carriage assembly. Let's bring it in. There it is. And the way I put mine in, I actually put it where the bearing was facing upwards towards the nut. So we'll do the same thing. That means that this and this were concentric. And let's check to make sure we got that right. Oh, no, it didn't do it the right way. So I'll expand the mate over here. And I'll right-click on this concentric mate and edit features. And we can flip the mate alignment. So that put it the direction that I was hoping it would be. So click OK. Click OK again to get out of that mate command. Then this surface and this surface will be concentric. Okay. And now this can move up and down. Now, we can get into a little bit more precision than I'm really willing to do. I did take the trouble to actually model the helix, which I don't always do when I'm doing something like this. Very often I would have made just this shape right here and just labeled it as being a helix. But it wasn't very difficult to add that, and I wanted to be able to see. What I'm not going to do is try to line up the threads in here to make the two of them work correctly. What I am going to do is I want this to move up and down like it's supposed to. And I want this to rotate as it's moving up and down. I also want to limit this so I can't put it in a position that it's not physically capable of putting it in. So in order to do that, I'm going to actually go into the make commands and we'll go from there. So I'll go to the make command. We're going to use two different types of different mates. We're going to go to the advanced mate tab and we're going to use this distance right here. It's called distance. And if you notice when you click on it, some new values come up here. Are what we want to do, we want to use this surface and this surface. Okay. And I want the minimum distance that it's allowed to be is 0. And I'm not sure yet what I want the maximum to be. So I'll show you how to change it. I think I'm going to make this be maybe 15 millimeters for now. And we'll need to come back and change that later. But I want you to see what this is doing. So this is called a limit distance. I'll click OK. And if I grab this to move it, normally when I'm trying to see if something will move, I'll look for a point I can grab. So I'm going to grab this point right here. I can come up 15, and if you notice it stops. It won't let me go up any further. And when I go down, it will stop and not let me go any further. So I can go between 0 millimeters and 15 millimeters at that distance. So what I'll do is I'll put it all the way down to the bottom. I'm going to click OK so I get out of the make commands. And what I would like to do is I'd like to know how much it can go up before this component right here, so I'll click on it, hits that component right there. If I hit Control and click, so those two surfaces are connected, down here at the bottom it actually gives me the distance, and it says that 23.88 millimeters is the distance from that top of the gold face or bronze face to the bottom of the aluminum face. Now that I know that that's 23.88, I'm going to call it 23 millimeters. Let's go back to this limit distance. So the Z carriage is the thing that can go up and down. That's this. And I'm going to edit this limit distance. I'll edit that feature. And instead of stopping it at 15, we can stop it at 23 millimeters. So we'll click OK. Whenever you see the red light, green light, that means it's possible to rebuild the assembly. Let me click the rebuild button. And if you notice the Z carriage, even though it's still capable of moving, the minus sign is now gone from that side. And the reason it's gone is, let me rebuild again. It's allowed to move, but we have constrained that axis. So SOLIDWORKS understands that we're letting it move the way that we want to let it move. I've got one more mate I want to put on, and this is just to be a little bit fancier for display purposes. I'm going to go back into the mate command, and instead of at advanced this time, we'll go to mechanical mates. And the mechanical mate I'm interested in is the one that's called the screw. And what we need to do is we need to find something related to the thing that's rotating. So I'll choose this edge here. And maybe if we can find some round edge on the stationary part, this is a stationary part, so that edge would work. Okay, so it shows now that there's some relationship between those two. I'm going to change it to distance per revolution, and we want it to go 2 millimeters for 1 revolution. That's the pitch on the screw. So that'll make it move correctly. So I'll click OK. That accepts that mate there. Now when I drag this up and down, oops, let me get out of this mate command. Let me rebuild. Okay. One thing, now that I've added that relationship, notice the two things that had rotational movement. There's one of them. The minus sign is gone. This is actually fully defined now. If I grab this point right here and move it, it should have allowed motion. So let's see what's going on. That screw. Oh, I know what's wrong. When I chose the things that could move, what I needed to show was the thing that was rotating and what it was rotating relative to. So let me edit the screw and fix that. I'm going to edit the feature. And the thing that was wrong was this edge 2, this top edge that I clicked second. I'm going to delete it. Nope, that was the right one. So let me reselect it. and it's the top one here at the X carriage. I'll delete that one. And instead of that one, let's use something that's round on this side. Here we go. And click OK. And OK. Now when we move up and down, the thread rotates. Again, even though that carriage, even though this coupler is allowed to rotate, since SOLIDWORKS knows that I've given it a mate to control it, it's considering it to be fully defined. And this finishes off our assembled component. Click Save, Save All, Rebuild and Save, and we are finished with our assembly.